So, I think it's been about a year or whatever since I've uploaded a STEM video, and well, I think it's time to upload one. So, I was doing some practice with limits, just a little bit earlier. It's been a while since I practiced limits specifically, and I was like, okay, time to, refreshen myself on this. And I came across this one, and I was like, oh my gosh, I don't know exactly what to do here at all. And that's when I went to the help and from the videos, that the help videos from the book, and I learned a new technique that was really cool. Um, this is mostly useful for limits, but it's just learning a new way to manipulate form expressions in general. So in this case, you have this situation as we're looking at here, and with limits, as hopefully you may be already aware, this is the limit of x as it approaches negative infinity. You want to find out what this approaches. So you can already tell that the top part will already approach negative infinity, and the bottom part will already approach the square root, or the negative square root of, the square root of negative infinity minus, or well, plus infinity. And that's really confusing. That doesn't really make any sense for what we're trying to do here. It doesn't accomplish anything. So when we have indeterminate forms like that, of course, we have to recast the expression so we can do something with it, find out the answer. And I was like, when I'm first learning this, I'm just like, how does this make any sense? I'm confused with the whole idea of it because to me it's like, if it's the same thing, it's the same thing, right? So why are we able to find a solution if it's the same thing? And that's when it came to my mind to think of it like water. It's like sometimes you're thirsty, but you have a whole lot of ice, so you got to somehow find a way to melt the water, and then you have water to drink. And of course, if you do it right, it's still going to be nice cold water because it was just ice. Anyway, it's all H2O, the same chemical. Let me write that down. So that's the big thought. It's that it's all still H2O, which is just water, but you can have the frozen form of it, which is ice. You can have the liquid form of it, which is water, or you can have the steam form of it, which I'm going to draw this way, which is steam, or a gaseous state, basically water vapor. And these different things are useful for different purposes. If we wanted it for thirsty, but we only have ice and we have to melt it, and then we have H2O in a form that's usable for our needs now. With these mathematical expressions, it's the same way. It's the same chemical, basically, but the expression's different, so we catch it in a different form. Again, with the water, if we have too much water, we can freeze it, and then we can make some ice cubes out of it. And then we can keep, cold drinks. And so it's the same kind of deal here. So we want to recast this thing into a different way, and just like with our water example, now we have a way to appreciate this formula that'll give us its limit. And so the technique that I learned from watching that video was to divide both ends by, well, let me just make it clear. We want to use an identity property. So that's kind of obvious that we want to do is an identity. Essentially, we're going to use the division, is it quotient? The quotient identity, which is x over x equals 1, or negative x over negative x equals 1, either way. So we're going to want to use identity, something like this, in this to solve this, to recast this expression. And so if we know that x over x is 1, except we're going to get a little funkier with it. And this is where I thought it was just cool to me. So we're going to divide the top part by x. So basically what we're going to do is we're going to do x over the square root of x2. Now, at first this looks different, then you're like, wait a second, that is just 1. Because the square root of x2, if you just process that a bit, of course, these two things cancel out, and it just turns out to be x over x, which is 1, right? So it's still x over x is 1, it just seems a little bit oddly too complicated, until we come across something like this. So then our top part's going to be x over x. Our bottom part, however, though, is going to be this, x squared minus x, all under the radical, divided by the square root of x squared. Now, I forget the exact reasoning behind this, but it needs to be a negative on the side. I think it has to do with the negative infinity limit to it, if I remember right. So this does have to be negative on the outside of the radical. Anyway, so that means we have two divisions going on here. And so what happens is that this one, on the top, this just becomes 1. So we already have the top there. Now what happens to the bottom? Well, the bottom, since they're now all the same radical, they share the same radical. And of course, the negative still goes on the bottom here. So now we have that. And so it becomes x squared minus x over x squared. And so remember, the radical covers both of these now. Well, as you can tell, what ends up happening is there's some cancellations. So it becomes 1 over negative. And so that becomes 1 minus x over x2. Now, we can't really... At this point, we've reached the limit, pun intended, I guess, of what we can do to manipulate this formula. Or, I keep saying formula. It's expression. We've reached the limit. Once we get to this point, we're just going to be running in circles all over around. And we don't have to worry about this anymore. So we have to say, what does everything approach as they approach negative infinity? And we're going to say, well, 1 is just going to stay at 1. This one can go outside the radical, so this one becomes negative 1. And then we have this next part that's in the radical still, and that essentially will just go down to 0 as x approaches infinity. This thing will, this fractional part goes to 0, so we don't have to worry about that anymore. And so essentially we have 1 over, so we're just going to block that out. Since that basically goes to 0, we can ignore that. Well, we have 1 over negative 1, and 1 over negative 1 just equals negative 1. So the limit works itself right out. Limit as x approaches negative infinity is negative 1. And, that was the thing I learned. Just learning how to divide by learning how to divide the x. The basic pattern here is we just want to take the biggest x factor. We just, whether it's a polynomial expression or otherwise, we just think about the biggest x factor and we divide by that. So the biggest x factor here is x, and the biggest x factor here is x squared, or the square root, the negative square root of x squared. And so that becomes our target. And so when we have x over the square root of x squared, that's still the identity property 1 over 1. Which is 1. And anything multiplied by 1 is itself. So we just have a whole list of identities. I just never thought about it that way, that you can technically have a numerator and denominator with two different things, and they can still lead to an identity. At the same time, you can stack them on like this, and you get some usable form with it, and then you get the answer. So that's pretty cool to me. So I just wanted to pass that along, and also add another video to the thing.